Hi guys, and welcome to the first video lesson of the new chemistry academic year. I'm Mr. Burns, if you haven't met me before. What we're planning to do with you over the next few weeks, certainly until we get back to school, whenever that may be, is do a number of video lessons. The PowerPoints will all be on there and there'll be lots of tasks for us to do, and I'll be online at the specified times to help you as well, okay, and answer any questions that you might have. But hopefully the videos should do most of the explanation and should minimise the need for you to be online and focusing when I'm online, okay? So the idea being that yes, you can come online and focus on your chemistry at that time, but if something is stopping you from doing that, then it's not the end of the world, okay? We're going to start off with Unit 2 for a number of reasons, but mostly because Unit 2 leads on from what we were doing in S3, so it should be a nice natural follow-on for most of us. And as you can probably see from the title of the PowerPoint, we're going to be looking at fuels, okay, which is familiar to most of us from S3, okay. So the learning intentions: state the definition of a fuel, understand what the fire triangle is and why it is important, understand what fossil fuels are and how they are formed, explain how fossil fuels are formed, and state the products of complete and incomplete combustion. Now, none of those, I know there's a lot of learning intentions there, but none of them are new to us, okay? They're all things that we've covered in the last few months in S3, okay? We were looking at the rocket stuff. We looked at fuels. So it's all the same things. So we're just going to be revisiting that, making sure that that's clear in our heads. Success criteria for this lesson: you are going to be asked at the end of the video to create a PowerPoint presentation, okay? So success criteria will be creating a PowerPoint presentation explaining how fossil fuels are formed, what global warming is, and how those two things are linked, how fossil fuels and global warming are linked. It's very topical in the news, so you should be able to find lots of information on the internet about that. Also, you should be able to successfully fill in the blanks and answer the questions in your notes. After every lesson, I will tell you what part of the notes to go to and fill in the blanks, okay? It's up to you, it's your responsibility to fill in your own notes, okay? Most of it is filled in for you, but you need to fill in the blanks. The lessons will help you do that, okay? Now, the notes are on the Teams files section, but it is important that you download your own copy. Please do not go in and try and edit the one that's already there. It's important that you download your own copy of that. If you don't do that and you edit the one that's in there, that's not going to get saved, okay? Because the next person that goes in is going to edit over the top of it, okay? It's going to undo all your good work. So please make sure you take your own copy. Okay. So, firstly, what is a fuel? Okay, it seems like a straightforward enough question, but I want you to take a few minutes, pause the video if you need to, and list as many fuels that you can think of. Okay, so let's pause the video and see if we can do that. Okay. Let's see if you got some of them that I got, okay? Here are just a few that I thought of. Most of them you'll know. Maybe one of them I would say you maybe weren't so sure about. Gas, like the stuff you get from the gas taps in school, that if you've got a gas cooker, it's the kind of gas that we would be using. Petrol and diesel for cars, lorries. If you've got an open fire in your house, or a campfire or anything like that, coal, wood, and to some extent, peat might have been used. Okay, peat's a fuel that is used in the north of Scotland quite a lot. It's kind of cross between coal and oil. It's a kind of strange thing to dig up out of the ground, but it's not solid like coal. It's almost like it's very earthy. Okay, oil, oil, for example, the kind of stuff that petrol and diesel is made from. Okay, we know that there's a lot of flammable oils there that could be used as fuels. Okay, which leads me to the question: what is a fuel? Okay, we can define a fuel, and that's something that we need to know as chemists, is the definition of a fuel. And fuels are substances which release energy when burned. Okay, every single fuel that you can think of does one job, and that job is to store energy. But what is important is that a fuel must also release that energy in some way. And for fuels, that energy is released when that fuel is burned. Okay. Now what that means is that the energy that's being released, more often than not, is going to be heat and sometimes light. There's lots of other forms of energy, like kinetic energy, that's the energy of movement. Now sometimes when we talk about, for example, petrol and diesel in cars, you think, well, that fuel is turning into some kind of movement energy there. That's not turning into heat and light. But that all happens in the engine. What happens is that fuel is burned, and that explosion that happens in the engine drives a piston up and down, and that turns the wheels. Okay, so it all comes back to that energy and that explosion, that release of heat. Okay, so the initial energy is heat. Energy can then change from one form to another, as we know. Okay, so that's what happens with all these different fuels and what they do. It really all comes down to releasing heat. Now, chemical reactions that release heat have a special name. Okay, these are called exothermic reactions. Ex meaning exit, heat. Exit, thermic, thermometer, heat. So I always kind of link, I try and make, if you see a word that you've maybe not seen before, it's quite scientific, try and break it down. This part, exit. Okay, something's exiting. Thermic, well, we've used a thermometer before, so thermometer measures temperature or heat. So exits, heat exits. So in other words, an exothermic reaction is a reaction which gives off heat. Okay? Now that's something that you are going to have to remember. That's a key term that you are going to have to remember, and I'm going to expect you to have remembered that. Okay? Now it won't happen immediately, but I will keep asking you about it, and eventually it will sink in. So, fuels are substances which release energy when burned. I'm going to give you another term. We've talked about it before in S3. Combustion. Okay, now it's just a fancy word for burning, but we're chemists now, we're interested in these scientific terms, so we're going to be referring to it as combustion now. Okay, and combustion is when we react something, usually a fuel, with oxygen. And that's what happens when something's burned. You're reacting it with oxygen. So, that leads me to my next question. What 3 things are needed for a fuel, or indeed anything at all, to burn? What 3 things are needed? If you need to think about it, pause the video. Okay. I'm going to move on. The 3 things that are needed for a fuel to burn, well, that leads us to our fire triangle. Fire triangle tells us the 3 things that need to be present in order for a fuel to burn. And those 3 things are along the side of the triangle on the right of your screen there. The fuel, first of all, must be present. That's the thing that's going to be being combusted or burned. when we burn something, we're reacting it with oxygen. So the second thing that must be present is oxygen. No oxygen, no fire. The third, and the one that kind of trips people up quite a lot, is heat. You think, well, the fire gives off heat, so surely it's not needed to start. But we do need we need heat there to keep the fire going. If we remove heat, then the fire will go out. Now I'm going to make you think a little bit about an example. Okay, if we've got a candle, okay, if you've got a candle in a little tea light candle burning, you might have a candle that's burning in the house just now. Okay, what are the different ways that you can put that fire out? Okay, well, you could just leave it, and eventually that's going to run out of fuel. Okay, the wax is going to run all the way down. When there's no more wax, there's no more fuel, so you've taken away fuel, you've taken away that first thing there, and the fire will go out. Another way that you could do it, you could cover the top of the candle, or you could cover the candle with a glass or something like that. After a few seconds, that candle would go out. The reason? Well, you've removed the air. Okay, as soon as all the air in that glass has been used up, all the oxygen in that glass has been used up, there's no more oxygen to use, and the fire will go out, even though there's still fuel and there's still heat. The third way, and probably the way most people do it, is removing heat. And you probably don't think about it like that, but if you blow on a candle, what you're doing is you're blowing cold air over that flame and you're removing the heat. As soon as you remove the heat, you put it out. Okay? Another way of removing heat is to put water on it. Water is excellent at absorbing heat energy. If you put water on a fire, you're going to put it out. Usually. There's a few examples where that's not the case. Chip pan fires, for example. Never ever put water on an oil fire. Okay? That causes it to explode rather than put the fire out. And that's more to do with the fact that water and oil don't mix. Okay, so if you put water and oil together, water will sink to the bottom and the oil will float on the top. If you add fire to the mix, if that oil is on fire, then what that water does when it sinks to the bottom, it turns to steam straight away and expands. Steam's a gas. It expands and it pushes that oil out, and so you end up with a big massive fireball explosion. It's not nice at all. There are some YouTube videos that show chip pan fires, so you can have a little look at that. If you did ever have a fire and it was an oil fire, what you want to do is you want to remove the oxygen. So rather than pour water on, what we want to do is you want to get a damp towel and you want to place that over the fire if you can. Okay, of course, if it's not safe to do so, what you want to do is leave it, phone the fire brigade. That's the main thing. But the important thing is don't ever pour water on that fire. Okay, so that, again, this is all the things that chemists can do. We have this knowledge, so we can work out which way is best, which thing to remove, which is the safest to remove to put that fire out. In most cases, removing the heat is a safe bet, but with oil fires, removing the heat is not a safe bet at all. The best thing to do would be to remove the oxygen. The important thing is, if you remove any one of these, the fire will not go out. The fire will go out, it can't continue, or if it's not been lit, if one of these things is missing, it cannot light. It's not going to be difficult to light, it just won't light at all. It's going to be impossible. Okay, so we've looked at fuels in general. Of those fuels that we looked at back in the first slide, can you think of the three main fuels that we would call fossil fuels? Because fossil fuels, you might have heard of them before, are the main source of energy around the world. Okay, can you think of what they are? No, there's the first one. Oil. Second one is coal. I've been cheeky here and I've put 2 in the one box here. We've got gas at the top and we've got peat down the bottom. Peat is a fossil fuel. It's formed in the same way or a very similar way to coal. Okay, and you're going to look at the ways in which these are formed in a minute. That's going to be your task. But what are these fossil fuels made from? You're going to look at how they're made, but what makes them up? Okay, well, interestingly enough, doesn't matter which one you're talking about, whether you're talking about peat, coal, oil or gas, they all only contain 2 elements. If you have a look at the periodic table on the screen here, I'm going to circle hydrogen and I'm going to circle carbon. These 2 elements are the only elements that are ever going to be found in a fossil fuel. And that's because fossil fuels are from a group of compounds being things that have more than one element in them, okay? 2 or more elements joined together. It's from a group of compounds and they're called hydrocarbons. Hydrocarbons. Now, again, looks like a really complicated name, but what did I say? If you see something that's really complicated, let's see if we can break it down. So let's split it down the middle. Hydro, well, that's hydrogen. And carbons, well, that's carbon. So a hydrocarbon contains only hydrogen and carbon atoms. So if all fossil fuels are hydrocarbons, then they must only contain carbon and hydrogen. Nothing else. No oxygen, no nitrogen, none of the other elements are in there. And in fact, coal is mostly carbon. Okay, there's hardly any hydrogen in there at all. Okay, which is really fascinating stuff. The fact that of all these elements, the things that we mostly use to give us the energy that we need to live contain only 2. Okay, and in fact, carbon is the element that we're made up of mostly. Okay, it's the element of life, and we'll talk a little bit about that very soon as well. Okay, fossil fuels. Why fossil fuels? The clue's in the name in terms of where fossil fuels came from. Okay, I'm not going to talk too much about it because this is going to be your task, but I'm going to start you off. So the word fossil, what do we think of when we think fossil? Well, I know I think old. And in fact, a fossil is a very old, I'm talking millions of years old, living organism. Okay, something that's died millions of years ago. We know what a fuel is. Our definition of a fuel, which we learned earlier, is something which is burned to release energy. So a fossil fuel is a fuel, something which burns to release energy and is made of very old, formerly living organisms, formerly living things that have died millions of years ago. And actually we're talking about between 150 million and 250 million years ago. Okay, so we're going prehistoric here. Okay, think dinosaurs. When we're talking about plants, we're talking about organisms, we're talking about plants and animals. Okay, plants, animals, sea creatures that lived 250 million years ago. They, like us, had energy, and when they died, that energy, because of the way that they died, was stored. So when we're burning, we've dug all that out the ground in one form or another. We get our coal. That coal is full of energy that was stored, that was in that 250 million year old creature. So when we burn that energy is released. So the heat that we get from a coal fire, for example, is energy that was in a living thing 250 million years ago, which I think is fascinating. But anyway, it's now up to you to do a task, okay? Your task is going to be to use the information in the video lesson and your notes, as well as the internet. I would recommend BBC Bitesize for this task. Okay, if you're using any website, we always need to make sure it's a reliable source, and we know that. BBC Bitesize is very good. If you go to the National 4 section, Chemistry, National 4, Unit 2, you'll see a section there on fuels, and that will give you all the information you need about how coal, oil and natural gas were formed. Okay, you can use other sources as well, but please make sure that they are reliable. And what you're going to do, you're going to create a PowerPoint or a Sway presentation explaining how coal was formed, how natural gas and oil were formed, what the term finite means, and how this is related to fossil fuels. So, are fossil fuels finite or are they infinite? Okay. What global warming is, and why fossil fuels are being blamed for global warming. Okay, is there something that they give off which causes global warming? What is global warming anyway? And why do we need to worry about it? The difference between fossil fuels and other forms of fuels such as biomass or wind power. Okay, we might not have done a lot on biomass or wind power. Have a little look at it. Okay, list the pros and cons of fossil fuels versus, for example, wind power. And I would like you to decide which one you think is best, which one you think is best and why. Which one do you think we should be using more of? When it's complete, I want you to upload this to your class notebook. Okay, I will give you feedback. Your class notebook, there's a folder in notebook, class notebook that's yours. If you upload it there, only you and I can see it. I will give you feedback. It might not be immediate feedback, but I will give you feedback eventually. This should take the rest of the period, okay? I want you to do your very best work on it. Like I said, go back, listen to my dulcet tones if you want, if there's things that you didn't quite catch the first time round. I will also be online at the designated times, okay? When you're meant to be in chemistry, I will be online and I'll be able to help you with all this, okay? And I'll be talking to you throughout. But this is here in case, for whatever reason, you can't make it one of the times. You can go on, the lessons will be there, and you can just do the task, okay? Once you've done that task, you now have enough knowledge to go to your notes and fill in the blanks on pages 1 and 2. Okay, now again, you might have to go back and look at the video to refresh your memory, but you should have enough information there to go ahead and fill in your notes. And these notes is important that you get them filled in and as accurate and as complete as possible, because these are going to be your main source of revision when it comes to exam time next year. Okay? Right, I'm going to let you get on with that task. I will be online. Feel free to ask me any questions. If you need any questions or just having a chat with me, I'm more than welcome. Just have a chat with me. But I will let you get on with that. Thanks very much for watching, and I will see you next time.